Okay, so new model. Okay, so SI Indian, this is steel and concrete coat, right? Okay, so first initially it will ask you the grade option. Okay, so here is already 4 is there, 8 meter. I will take it as 5 meter, right? So generally here the number of stories height is 3 meter. Bottom it will be generally around 2.8. Okay, so this is bottom story. So now the grade. I will basically focus on all the three earthquake analysis. Okay. So first what I will do is first I have to define the material. Okay. So add new material. Okay. Indian. If you want to make concrete, Indian M30. Okay. So M30, then I will make it as M25. First you have to do the material property. See now in the previous course you have to change these values. Now we need not, just you give M25 automatically with respect to M25 what is Young's modulus, what is Poisson's ratio, everything automatically it will take. Okay, so that is I have defined. So now after that I will take the steel, right? So for that you have to go to rebar option. Okay, reinforcement. If you give steel it will not give, so you have to go rebar Indian and it will, you have to define the grade. Okay, so then accordingly it will give all the values of that Fe415. Okay, so it's already HYST 415 is there. Okay, so now once first define material, then the cross sections. Okay, so there add new property column. Generally for the beam they will first give B. Okay, so then after that for the 5-story building, right, I will take 300, okay, by 450. Okay, so after that the grade of the concrete you have to choose. Okay, so then now it is beam, I will choose M25. Okay, so then the concrete rectangle, then here the depth plus 300. Okay, so here modify, so this I will tell you later. Okay, reinforcement, here it has to be checked and deformed. So here you have to give the HYST 415 and the space, the cover it has to be around, for beam you can give around 25. Okay, so this you have to give option as beam, otherwise it will design as a column only, so you have to choose this one. Okay, so here I will give 25, 25. Okay, so this is I have defined the beam. Next add new property, then again column, I will just give C 400 by 500. Okay, so I will give grade M30 only, so depth 500, 400, then here option column only, right? So here I'll give it as 30 mm. Okay, so done. So next is I have to define the slab, right? So frame section, slab section. Okay, add new property. Here I will just write yes around 250 mm, right? So M30, you take it as M25. Okay, so you have options. So in the software, if you don't want to consider the slab action into your software, you can choose membrane. Okay, if you want either you have to choose membrane or shell thin. Okay, it is not a thick shell. Okay, so that's why you have to take shell thin. Okay, so shell thin option and slab, then here around 250. Okay, so then okay, so see, one more thing I want to tell you is, see, if you take the shell thin option, so what it will do is it will resist the load. The slab will resist the load and then it will transfer. It will take the load and it will undergo the bending and then it will transfer the remaining forces to the beam and a column. But if we choose as a membrane, automatically 100% all the load will be transferred to the beam and a column. Okay, so it will not like not resist. So generally what will happen is, actually in the building the shell thin option, but generally what will happen in the your design companies, some companies will directly do the analysis design by excel sheets, so that time they will choose a membrane option. Okay, so the ideal condition, like what actually the building is undergoing, is shell thin option. Okay, so this you have to choose. So this is just 250. Okay, so then these are the options. Then I will do that this first, this one, all stories, I will just give the column. Okay, so here column 400 by 500. Okay, so this is completely all the floors it has been assigned. Okay, next comes is a beam. So then I have to give for the only similar stories. Okay, okay, so now it has been done. So next comes the slab. See, I told you, whenever uh, there is an regular, you can go with this one. Okay, so you are asking, right, whenever there is an irregular structure, there is no difference at all. Only thing is your position of the column and beam may vary, but when you are modeling, you have to choose this option. Okay, and connect those nodes. It may be 3 nodes, it may be 4 nodes, it may be 5, it may be any number of nodes. So you have to connect like this to all this, and then you have to do the meshing of that. Okay, so uniform meshing you have to do. Then after that you have to analyze. So FEM will take that irregular shape building and analyze. Okay, that is the only difference, is you have to play with this slab option. Okay, so now it is this thing, so I will just go to normal one. Okay, so whenever rectangle, you can just go with this option. Okay, so now this has been done. Okay, so next thing is, like, to do the earthquake analysis, right? So first what I will do is, I will assign the first, will select the slabs. Okay, so floors. Okay, then I will assign the load. Okay, to the shell loads, uniform loads. Okay, wait, select, already selected, right? Assign loads uniform. Okay, so here I should give my live load value. Okay, so what I will do is, generally around 1.5 is sufficient. Okay, so for you want to give for kitchen, or you want to give it for libraries like that, and then you can go up to 2.5. Generally for other places it will be given 1.5. So what I will do is, I will take it as 2. Okay, so you refer your IS 875 code, right? So then it is already gravity. Okay, so you can see it is applied. Okay, so if you want to apply the wall load, so how you have to do is, suppose the wall is, what I will do is, only one story. Okay, suppose you have a parapet wall, or maybe you consider that whole wall is there. Okay, so then what you have to do is, you have to just choose those walls. Okay, and then suppose the wall is only on this side. Okay, and you have on this side all the periphery. Okay, I'm going to choose like this. So then what I will do is, I will go to the assign frame loads, right, distributed. Okay, so there what I will do is, it is a dead load only, the wall load. How to calculate wall load is, just open the paint. Okay, so you see here, see all of you, if this is your wall, right? So what you have to do is, first your wall will be like this, right? So what you have to do is, first you calculate what is the length here, bottom. Note on the length. Okay. Suppose your length is, what is we have given, around 4 meter, right? So what should be the length of the wall? Then height of the wall. Height of the wall is generally you have to subtract the beam on the top. So we have given around how much, 3 meter, right? So what I will do is I will take around 2.8 meters. Okay. So height. Then the thickness around 0.23. Okay, thickness of the wall. So next, what, into the density of this masonry. Generally it will be, masonry wall density will be around 19 to 20. Okay, so length, okay, you can, somebody you calculate L, length is how much, it is 4, 4 into 2.8, okay, into 0.23 into 20. 4 is a length, height is 2.8 into 0.23 into 20. Okay. No, no, no. Here you should not consider, sorry, length is not there, sorry. Because you are applying a UDL. So only height, height and thickness of the wall. Height and thickness of the wall. 9 into 20. Okay, 12.88. Okay, 12.88 means I will take it as 13. Okay, so what I will do is I will do that 13. Hmm? So 13 kilonewton per meter is my load. Okay, so it will be replacing, not it is add to the existing. Okay, so apply. So you can see here, all of you see, this one is, you can able to see outer periphery. So if you want that, this goggle option is there, right? You have to click on that, then you will be able to see now. See that load, I will just show you. See the load what you have applied, right? You can see this wall load. Okay, so this is the option. If you remove this goggle, then it will not be visible. Hmm? So you can see, this is how we have to do. Okay, so this is wall load. How to apply the wall load? So that is, this is apply on the, you selected whichever the beam you want to put a load. So to calculate the wall load, you have to take height and thickness and into density, that is around 19 to 20. Okay, so this is with respect to wall. And then what now we have to define is, so first thing is you have to go to what is that, diaphragm. Okay, so diaphragm is, first, to assign the diaphragm you have to select all the slabs. Okay, so first what I will do is go to the select option. Okay, go to the object type, then floors, right? So I have selected all the floors, right? So then what, now assign. First I have to define the diaphragm. Okay, so diaphragm, see, add new. Okay, so it is D2. See, rigid is whenever, suppose if the steel connections, right? So if the steel connection is what, it is completely is welding, right? It is welded means it is a completely rigid. Okay, semi-rigid option is like where RCC. Okay, but even in RCC also, if the slab is very stiff, then again you have to take rigid only. Okay, so as of now I will take it as semi-rigid. Okay, so D2. Otherwise I will take it rigid only. So D2 option. Okay, D1 I will delete. Okay, this is a D2 is a defined. So now what I will do is I have already selected. So I already defined the this thing, and now assign the shell loads. Shell here, diaphragm. To go to the shell, there diaphragm and D2. Okay, so you can see here, you can see this option as a D2. So what is the meaning of this is, if you don't define this option, right? So whatever the horizontal forces you are applying here, okay, so I will just see, this is the elevation, right? So whatever the horizontal forces which is coming here, so this slab has to transfer that in a vertical direction to the beam and a column. Okay, if you don't define this, it will not properly do that. Okay, that's why giving this diaphragm information is most important. Okay, So when you assign this, what it will do is it will take all the horizontal forces which is coming onto this floor and it is transferring to in a vertical direction at this point. Okay, as a CG. Okay, so this is why the diaphragm option is to be given in the software. Okay, so the next option is the most important is mass source. Okay, so what is mass source here? You can just see here this option, mass source. Okay, so for that what you need to do is mass source you have to define, add new mass source. Okay, so here you can see I will just open the code in that what he has mentioned is uh, with respect to the live load, imposed load, um, if it is the live load is up to 3 or less than 3 condition is there. Okay, this table number 10, the percentage of imposed load up to or including 3 option, so reduce by 0.25. Okay, 25% you have to reduce. Okay, if it is more than 3, then reduce by 50%, because when the earthquake is happening, your 100% load will not be transferred vertically downwards. So that's why the reduction is this is with respect to that table number 10. Okay, so now what I have defined is 2 kilonewton my imposed load, so that is up to and including 3 means it is less than 3, so 25% I have to reduce. So what I will do is here I will take dead load as completely full, ठीक, then live load as 0.25. Okay, add. So this is the option I have to give. Okay, so then okay, so one I will delete. We have to define mass source, this one only. This modify here only, we will modify live load 0.25. Okay, it has been assigned. Okay, so this is a mass source. Okay, so unless until you don't define this diaphragm and mass source, your answer will never get properly in the earthquake with respect to earthquake. So now everything has been done. So now what I have to do is I will go to the load cases. Okay, so before that define load patterns. So here dead load, live load. Okay, so dead load is always the one uh, and see what is the meaning of that is multiplier means whatever the actual load of the dead weights are there, like beam, column or slab, into 1. Okay, so when it comes to the live load, okay, so then I will take the earthquake load EQ, okay, in x direction. Okay, then it is a seismic one, so option called as seismic. So you have to take this one and you have to choose your latest code. Okay, as 1893 2000, add new load. So next what I will do is I will do in a y direction. Okay, so then again that same thing, add a new load. So here in the EQX, when you are doing, you have to go to the modify. See, when you are taking in the x direction plus eccentricity, you can just take. Okay, so eccentricity, this option. So then next it is be to storify to base response reduction factor. Okay, so you have a code here, response reduction factor table number 9. So with whether it is the ordinary moment resisting frame means 3. Okay, so whether it is a special moment resisting frame means, this meaning is whether you are using 13920 code. Okay, that is a detailing with respect to earthquake, then only you can consider it as R is equal to 5. So structural walls, it is 1.5 to 2.5. When the dual system means the building width along this shear wall, so that is 3, 4, 4 and 5. So right now I will consider it as an ordinary moment resisting force. I will give it as R is equal to 3. Okay, so next, as per codal provision, suppose if it is, you think that the code is Sambhaji Nagar, right? So Sambhaji Nagar comes in zone 2. Zone 2 means what? The least value 0.1. Okay, that is the zone 2, it is point 2, point 1. Okay, soil type. Again, I told you in the code book, what it will done is the geotechnical person will Uh, geotechnical person will give you this detail soil data of the building where you are constructing. Suppose well graded gravel, well graded sand, okay, with 5% passing through 75 mm. So these are the classification. So he will give whether it is comes under type A, whether it is a rock or hard soil, type B medium or stiff, type C whether it is a soft soil. So out of these three, whatever the SPT value, see n between 10 and 30. So like this, you have to see the report and then you have to conclude what type of soil it is, type 1, 2 or 3. Okay. So based on that, you will get your SA by G value, and so that is what. So soil type, I will take it as medium. Okay. One hard, medium and soft. Okay, importance factor. Again, importance factor in the previous code it was value is different, in the latest code it is different. See, importance factor means how much the important is there during the building and even during the earthquake and even after the earthquake, because when the earthquake takes place, so hospitals plays a major role. If the hospital got destroyed, then you cannot do anything. So that's why how much the important the building is, to take that 1.5, 1.2, 1. Okay, so that option. So I will take this as a commercial building, I will take it as 1.2. Okay. So next soil type, then this you assume it as, don't try to calculate using your code book time period and then try to put SA by G value. So you just give it as program calculated. The software itself will calculate the base dimension and all, and it will calculate. Okay. So this is how we have to do it for the both EQX and EQY. Okay. So when I am telling Y, so this one, so 3, this is point 1, 2 and 1.2. So program calculated. Okay. So this is with respect to equistatic method, EQX and EQY. First you have to define these two. Once you do that, then you have to go to the load cases. Here you have to come to the load cases where EQX and EQY, linear static. Okay. So here what you have to do is, here it is linear static only. Okay. So so here, so for this you need not do anything. So it is just this much is defining is done. So once you do this, so what you have to do is just go to the then foundation. I have not given the fixity. Okay. So I will just go to the plan base. Okay. So then what I will do is I will select all the points here. Okay. Then assign the joint loads. So restraint. See, whenever you have a SPC is very good, then you go for a fixity. If SPC of the soil is not good, then you have to define it as a hinge. So that is the classification. Right now, I think that the soil is very good, the SPC of the soil, so I will take it as a fixity. Okay. So I have done that fixity. Okay. Then once I do this, everything is done, right? So uh, if you want the more accurate result, right? So for the building, what you have to do is, you have to go to the plan, story 5, and then what you can do is you have to select all the slabs. Okay. So select all the slabs, floors. Okay. So then what you have to do is, you have to uh, shell loads, not shell, shell. So here you have an option called as floor. Floor. You have one option is called as auto, right? So auto, and one more is wall. Wall also you can do floor auto meshing. See here, by default it is there. Okay. Or you can give how much the meshing you want, size and all. So that is what, see, this will be done for the things to get more accurate result. Okay. So this is what you have to do. So now I have defined the live load, I have wall load, and I have defined the dead load also. Now everything been done. So now I will give for the analysis. So I will save it as 1, 2, 3. Okay, so now you see when you are see the cases EQX. Okay, so you can just see the 3D view. So you can see the EQX, the movement, right? So EQX, right? So then you want to say that shear, right? So you can see the shear force, right? And then you want to see the deformation, right? So the deformation with respect to EQX, right? So then, mm, so you can see that. So you can see the deformation how it has taken place, right? So you can see this deformation, and you can start the animation also. This is also you can right? So it will give you the different motions how the building is going to happen. So I told you there should not be a torsion. To redesign the orientation of your column. Okay, so that is what you have to do. Okay, so that is a thing you should understand. So this is with respect to the equistatic method, and then how to see the results is display story response. So if you see here option EQX, right? So this is the displacement what you have. Okay, this is the maximum displacement at the story 5. Around how much it is? 12. Okay, so in the EQY direction, if you want, it is the EQY direction. It is around 12.5 around. Okay, this is with respect to maximum story displacement. This is the story drift. Okay, so no, this is a maximum story drift. What you can see. So this is a story drift. So next story shear. Okay. So these are the three parameters what in the earthquake most important thing you want. Story displacement, story drift and maximum story shear. Okay. So you have to calculate this and it will generate you the report also. Okay. So summary report if you give, it will show you the results. Okay. So if you want that detailed report also it will give you. So here the values. So here it will give you the values. Okay. So this is what you have to do to get the values. Then if you want to see the values, right? So display, go to the tables, show tables. So here the analysis results. Okay. In that the joint output reactions, joint reactions. Okay. So select the load patterns. Okay, not an issue. So here it will give you all the values. So joint reactions. So what you can do is it is showing lot of values. So what I will do is I will take only one thing, joint information, analysis results, output reactions. So I will take only earthquake. Okay, so you can see earthquake X, right? So you can see Fx. Okay, this will be your Bayesian value, Fx. Okay, so EQy, this will be your Bayesian value. When earthquake X is there, then okay, you can see in Y it is 23. So this is your VB. VB is nothing but what? It is H into W. So this is how it has to be calculated. Okay. So Fx value is what? It is earthquake X. So here it is giving you this value. So then again, if you still want more report, so create a report, show summary report. So there it will show you all the details. Okay, so VB, H, W and all what I told you, it will be calculated here. Okay, so this is how you need to do.